Hello folks, we're going to spend the next couple of weeks looking at something called completing the square, which is amazing. Let's go. So completing the square starts with spotting a little bit of a pattern. I'm going to expand a few of these. I want to see if you can see what's going on. If we were to start with x plus 3 all squared, that means that we are doing x plus 3 times x plus 3. If we expand that out, we'll get ourselves an x squared plus 3x plus 3x plus 9. And that'll get us to x squared plus 6x plus 9. Okay? If we try and do the same thing with, say, x plus 4, we're doing x plus 4 times x plus 4. That's x squared, 4x, and 4x, and 16. And so overall, that's x squared plus 8x plus 16. Now, if you fill the rest of these in, then you might be able to start spotting a little bit of a pattern here with what happens when we expand any sort of square bracket. I put this in a table to sort of make it easier to see. You can see there that if we start with x plus 3 squared, we end up with 6x and 9. If we start with 4, we end up with 8 and 16. If we start with 10, we end up with 20 and 100. And the connection there is that the number in front of the x is double this number, so 3 doubles to 6, 4 doubles to 8, etc. And the number at the end is that number squared. So 9 was 3 squared, 16 was 4 squared, 100 was 10 squared, and so on. So if we wanted to say in general, if we were to do x plus b all squared, then it would obviously start with x squared, because all of these have. And then we'd have two lots of that number in front of the x, so we'd have 2b in front of the x, and then we'd have that number squared, so we have a plus b squared at the end. And we can see a similar sort of pattern when the numbers are minus. So again, we sort of double the fact minus 3 goes up to minus 6, minus 4 goes to minus 8, minus 10 goes to minus 20. So that's doubled, so x squared minus 2bx. And then the number at the end is, it's a square, isn't it? And it's a plus. Squares are always pluses in this case because you're either doing a positive times a positive or a negative times a negative. So we'll end up with something that looks like that. And this is the general trend that we're going to use to do this completing the square job. So what we have is this formula here, and all we're going to do is just rearrange it a little bit. I'm going to take my x plus b squared, I'm going to subtract the b squared from over here, and that's going to leave me with just x squared plus 2bx. I'm going to end up with that as a formula, just flipping it around. Now, what does this mean? It means that we can rewrite expressions which look like this into expressions that look like the right-hand side of that equation. We can turn it into a square and an extra bit. This is sort of where the phrase completing the square comes from. So let's look at this x squared plus 8x as an example. Now, bear in mind we're going backwards this time. So we're saying we're starting with here and we're trying to get back to the right-hand side. So the 8, or the number in front of the x, is the only thing that really changes. So we take that 8x and we say, well, that's our 2b. So b is equal to 4. We're essentially going to halve that number there. And we're going to say that this is therefore x plus 4 all squared, because you can see in the bracket it's just b squared. Take away b squared, so take away 16, take away 4 squared. And that's it. What about for the second one? Okay, so our 2b is 100, so our b is 50. So this must be x plus 50 all squared, take away 50 squared, so take away 2,500. What about if it's a number like this, 3? Now there's two schools of thought on this one. Some people like to, you're obviously going to say 2b is 3. Some people like to halve this and say it's 1.5. And this is a perfectly fine way of looking at the world. We can say x plus 1.5 squared, take away be 2.25 if we square that, and that's fine. Some other people like to look at this and say b is 3 over 2, keep it as a fraction. And the reason you might want to do this is fractions are a bit easier to square than decimals on a non-calculator situation. So instead of writing 1.5, we write 3 over 2. And if we square 3 over 2, that's 9 over 4. 3 squared is 9, 2 squared is 4. These are both options that you can choose. One isn't better than the other, one isn't right and the other's wrong. They're both fine. What about this last one? Well, again, we could approach this in two ways. We could say b is 0.75. And I'm definitely in a situation where I'd have to square 0.75 on my calculator. 0.5625. Or I might want to say that b is 3/4, and so this is x plus 3/4 all squared, take away 9/16, because again, just square the 3. So yeah, all we do is we look at the number in front of the x, we halve it, and then we plug that into this formula. We're just rephrasing things in terms of this completing the square form. We can apply the same sort of thing with the minus rule that we just looked at. So we could, again, subtract the b squared here. And then just flip the order of the equal sign there. So x squared minus 2bx is x minus b all squared minus b squared. And we can do the same thing with these four. We can try and rephrase them from looking like the left-hand side to looking like the right-hand side. And it's always just about saying, well, 2b is equal to this, so I need to halve it to get the numbers on the other side. So let's do that. First one, we'd say 2b was 8, so b was 4. So this is x minus 4 all squared. Again, we're halving that. Take away 4 squared, so take away 16. We've got x minus 15 all squared. Take away 225. We've got, again, two options here, remember. We can say b is, 2b is 3. So b is 1.5 is definitely an option here. We can say x minus 1.5 all squared minus 2.25, or we could use the fraction 3 over 2, and we could say x minus 3 over 2 all squared minus 9 over 4. Both valid options. What about this last one? What's b here? Well, if x is just on its own, then that's 1x, so 2b is 1. So our value of b is either 0.5 or it's a half. So we could have x minus 0.5 all squared minus 0.25, or we could think about it as the fraction 1 over 2, and we could say this is x minus 1 over 2 all squared, take away a quarter. Now ultimately, what we've just done on those two slides is all you'll really need to know this week. So feel free to stop, go back, look over those two again. It's just all about using this formula here to rephrase stuff from left-hand side to right-hand side. Now it is more than likely that what you're given, the equation or expression, will not just be the x squared plus 2bx. It'll have some extra junk that you have to deal with. And we deal with that in a very clever way, which is just ignore it until we've done the completing the square. I'll show you what I mean. So I've got here x squared plus 16x plus 7, and I want to make it look like this thing on the right-hand side. Okay. What I'm going to do is I'm going to say, all right, plus 7, just go away for a bit. I'm going to deal with this x squared plus 16x. Now again, the number in front of the x is our 2b, so that's 16, and we need to halve that, 8. So we'll have x plus 8 all squared, take away 8 squared, take away 64. And now I've done that, I say, oh right, yeah, plus 7. So just add it on to the end. You don't need to work it into any of the calculations you do. You just sort of stick it on the end. And then we can do an extra sort of simplifying step here, because we wouldn't say minus 64 plus 7. We would say that overall that's minus 57. So what about the other ones we've got here? Well, if we had x squared plus 3x minus 12, I'm going to commit to the decimals for this one, I think. I'd say ignore u, minus 12. 2b is 3, so b is 1.5. So this is x plus 1.5 all squared, take away 2.25. Oh, and minus 12. Can definitely simplify that by combining these two together. That's not a case where two minuses make a plus, it's a subtraction and then another subtraction, so it goes down to minus 14.25. What about the two below? Well, the two below are going to use like the bottom of our two variants here, where we've got x squared minus 2bx. It's very similar, isn't it? Basically, it just changes this sign, so you can just remember one version. Let's do that. Again, ignore the minus 9. We'll say 2b is 4, so b is 2. So we're going to x minus 2 all squared, take away 2 squared, take away 9. Tidy it up. We've got x minus 2 all squared, minus 13. What about the last one? Ignore this. 2b equals 1. So b is, let's use fractions this time, a half. So we'd have x minus a half all squared, minus a quarter, and minus 1. So tidy that up. X minus a half all squared minus, what would that go to? 1 and a quarter, so 5 over 4. So hopefully, so far, so good. We're just expanding what we did, one extra step. And we're going to do that again. So we're almost at the stage where we can say, and here's the point of doing that. Because we've been looking in the last few weeks at solving quadratics. We had a look at doing factorizing. We had a look at using the formula, and we're going to look at a way that we can also do it using completing the square. So let's just briefly recap the ways we already looked at. If I wanted to solve this through factorizing, what would I want to do? I would want to find two numbers that times to 35, that add to 12, and those numbers are 5 and 7. And I would know that means my brackets are x plus 5 and x plus 7. So my answers are minus 5 and minus 7. Or I might think, no, I want to use the formula on this. And in that case, I would be saying that a is 1, it's the number in front of the x squared, b is 12, and c is 35. And I'd put them all into the formula. I'd say, so x is minus 12 plus or minus the square root of 12 squared minus 4 times 1 times 35 all over 2. I promise this will get a little bit nicer looking. We'll have minus 12 plus or minus, and then this square root here. So that's 144 for the 12 squared, and that's 140. So we'll end up with plus or minus the square root of 4 over 2. But the square root of 4 is just 2. And then if we think about this, we've got one case with the plus sign. So we could have, as one answer, would be minus 12 minus 2 over 2, which ends up being minus 7. Or we'll have minus 12 plus 2 over 2, which ends up being minus 5. So we do actually get to the same answers, which is useful. But as I said, we're introducing another way of doing it with completing the square. And completing the square would be saying, so in this case, let's say completing the square, 2b is equal to 12. It's equal to that number in front of the x. So b is equal to 6. So we would have x plus 6 all squared minus 6 squared, so minus 36. And then don't forget that we've got this plus 35 at the end. And we're saying that equals 0. Now, what can we do with this? Well, we already know that we can tidy up. Minus 36 plus 35, that's just minus 1. That's fine. What would we do after that? Well, we want to get x on its own. So rather than expand our brackets, which I think is a bit of a natural inclination here, we're going to add 1 to the other side. And then how do we get rid of a square? Well, we're going to square root. And if we square root a number, we have to be very careful here. So it's going to get rid of the square root there. What's the square root of 1? Well, 1 is one of the square roots of 1, because 1 times 1 is 1. But there's also minus 1, because minus 1 times minus 1 is 1 as well. So this is where our plus minus sign is going to come in. The square root of 1 is 1, and it's minus 1. There's two possibilities there. Now what have we got? We've got x plus 6 equals this thing, but we just want x. So we're going to take away 6. If we do that, we'll end up with x equals, and then plus or minus 1 minus 6. So just like we had with the quadratic formula, we now have two different answers, one where we use the plus sign and one where we use the minus sign. So we could either say that x is plus 1 minus 6, which is minus 5, or we could say x is minus 1 minus 6, which is minus 7. Again, the same answers. That's as you'd expect. All of these methods should give us the same answer. But I think just like with the quadratic formula we looked at last week, there's like situations where you'd use one and the situations where you'd use the other. In this case, I would always use factorizing because factorizing is quick and it's cheap and it gets to the answer. Completing the square, the formula are for where you can't see the answer quite so easily. Let's look at some examples where completing the square is good. So here's R2. You are more than welcome to pause the video and have a go first, but I'm going to crack on with it. As I say, most important thing is saying what b is at the start. So 2b is 10 in this first example, which means we're going to end up with b being 5. So we've got our x plus 5 all squared, take away 5 squared. So take away 25, plus 3 equals 0. And then step 1 is going to be tidy that up. Let's actually write down what we're doing. So we completed the square and then we tidied it up a little bit. What would we do then? So we're going to add 22 to the other side. And then we need to get rid of this square root, this square, sorry. So we are going to square root. And we've got to remember if we're going to square root, there's a plus or minus involved. So I'm going to write down plus minus square root as the step there. And then our last step would be to subtract the 5. So we'll end up with, let's stick it at the front actually, minus 5 plus or minus the square root of 22. So there we go. Those were our 5 steps that we did there. Completing the square, tidying it up, adding 22, square rooting with a plus or minus sign, and then taking away 5. Now on the previous page, we could do something from here because the square root of 20 of 1 it was, wasn't it? Is there something we know the answer to? But we don't know the answer to the square root of 22. So actually, all we do is we just leave it like this. You can actually give this as your answer, and that's fine. Or you might want to go to like saying, well, there's 2 separate answers here. So we can either say x is minus 5 plus the square root of 22, or it's minus 5 minus the square root of 22. You know, that's a valid option as well. But this is a perfect example of where completing the square is good because we can't factorize this. And if we tried, we could obviously use the formula, but this is something that might be asked on a non-calculator paper. And it's a way of getting to this answer without having to use the quadratic formula. Let's try one more of these, okay? Again, more than welcome to have a go yourself first, but I'm going to go for it. So I'm using the bottom version of the formula here with the minus sign. I'm going to say 2b is 7, so b is, let's use fractions actually, yeah. So b is 7 over 2. I'm going to go into my completing the square, so x minus 7 over 2 all squared, take away, remember if we square a fraction, square the top, so that's 49, square the bottom, so that's 4. We've also got minus 5 is 0 here. So that's my completing the square step. I'm going to try and tidy this up. Now it's worth saying that 5 is 20 over 4. So if I was going to take away 5 from there, I think I end up with minus 69 over 4. So we'll have x minus 7 over 2 squared minus 69 over 4 is 0. What's our next step? Our next step is to add across. So x minus 7 over 2 squared is 69 over 4. Then do the plus or minus square roots. So x minus 7 over 2 is plus or minus the square root of 69 over 4. And then lastly, add our 7 over 2. So we'll end up with 7 over 2 plus or minus the square root of 69 over 4. That's it. That's how we solve with completing the square. Now, The last thing we could do here, I suppose, is introduce yet more junk, but the method for these is going to remain the same. Again, pause if you think you want to have a go first, but I'm going to go for it. In previous situations, we've said that we need to get one side to be equal to 0. That's not quite true with the completing the square method. We just need all of the x's on one side. We can kind of ignore the rest of it. But I am going to move everything to the left-hand side and make the other side 0 because I think it's good to be consistent at this stage. So we'll do that first. We'll say x squared, and we need to add 5x, so we're going to have plus 9x, and we need to take away 3, so plus 6 is 0. And now we're in our completing the square situation, so here is our 2b. Our 2b is equal to 9, so our b is, let's use decimals, 4.5. So we go into completing the square, so x plus 4.5 all squared, take away, what's that squared, 20.25 I think, plus 6 is 0, so we would then tidy up, so it's minus 14.25, we'd add the 14.25 across, we would square root and make sure that we remember the plus or minus when we square root, and then we'd subtract the 4.5. Job done. What about the second one? Well, do the same thing. Get everything on the left-hand side. We're going to subtract x squared this time. So we're down to x squared. We're going to add 7x. That'll put us all the way up to 4x. And we're going to take away 7, which there's nothing to take away from there, so that's just minus 7. We then go to say, so 2b is 4, and b is 2. And we just apply the same sort of thing. So we're going to have x plus 2 all squared minus 2 squared, and then minus 7 is 0. So x plus 2 all squared minus 11 is 0. And you know the pattern by now. We're going to add the 11. We're going to square root, not forgetting the plus or minus. And then we're going to subtract the 2, and we're done. So there we go. We've looked at simplifying in the form completing the square, and we've looked at solving using completing the square. Have a good one.